Unit circle drawn on the Cartesian coordinate plane, where this is x, this is y. By definition, a unit circle has a radius of 1. So if the radius is 1, this coordinate right here would be over 1 up 0. This coordinate would be over 0 up 1. This coordinate, I'm traveling to the left, so this is negative 1, 0. And then this coordinate down here is over 0 up negative 1. Okay, so there's my unit circle. The radius is equal to 1. So if I were to draw a triangle in that unit circle, oops. If I draw a triangle in that unit circle, I would get to this point by either traveling 1 unit at a certain angle, or I could go over x number of units and up y units. So this coordinate on my unit circle would be over x, up y. Always over and then up, always x before y. So then if I'm looking at my trig functions of this triangle, my hypotenuse is 1, I can see that cosine of x. Here, let me see. Cosine of theta is equal to my adjacent over my hypotenuse. So cosine of theta is equal to my adjacent over my hypotenuse. Multiply both sides by 1, and I can see that cosine of theta and x are interchangeable. Cosine of theta is equal to x, and x equals cosine of theta. Additionally, if I do sine of theta would equal the opposite over the hypotenuse. Right? Sine is opposite over hypotenuse, so this would be y over 1. Or sine of theta and y are the same. Cosine of theta and x are the same. So I could just get rid of those, right? Dividing by 1 doesn't change the value. So this coordinate, xy, could also be the coordinate x is replaceable as cosine of theta. So x could be cosine of theta, and y would be sine of theta. So you have any coordinate here on the unit circle where the hypotenuse is 1, where x is cosine of theta and y is sine of theta. So if I'm looking at my imaginary triangles right now, like at 0, 90, 180, and 270, those are all going to be imaginary triangles. The cosine of 0, so the cosine of 0 degrees would be the first term. So cosine of 0 degrees is equal to 1. Sine of 0 degrees is equal to 0, because this is cosine and this is sine. Cosine of 90 would be up here. Cosine would be the first term. Cosine of 90 is 0. Sine of 90 is 1. Cosine of 180 would be over here. Cosine of 180 would be the first term, because cosine's first. Cosine and then sine. So cosine of 180 is negative 1. Sine of 180 is 0. Cosine of 270 is 0. Just like sine of 270 is negative 1. So that's how you can figure out those 4 imaginary triangles. The other side is going backwards. So cosine of what angle is equal to 1. So this is given a dependent, looking for an independent. So I'm looking in these coordinates, where is cosine of theta going to equal 1? That's only going to happen at 0 degrees, right? Or at 360 degrees, or there afterwards. So cosine of theta equals 1 is going to happen at 0 degrees, 360 degrees, or any time that terminal side stops where my first value is equal to 1. So let's say, where is sine of theta equal to negative 1? Sine of theta equals negative 1. I'm looking for a y value at negative 1. And that only happens here at 270 degrees. I could also get to this terminal side by rotating negative 90 degrees. But when I'm given a ratio of sides going back to find an angle, I'll have an infinite series of solutions. I'm going to want to pick the one in the domain given. So this is how to find um, sides and angles and imaginary triangles on the unit circle.